night you disappear. Now, I want you to really think about what I just said, because I don't mean it as poetry. I mean it as a statement of fact. You lie down, you close your eyes, and at some point, the thing that is you, the awareness, the inner voice, the sense that there is someone home behind those eyes, it goes away. Curious. Your body stays right there. Your heart keeps beating. Your lungs keep breathing. Your neurons keep firing. Millions and millions of them all night long. But the subjective experience of being you goes dark, and then hours later it comes back. You open your eyes and you say, well, I slept well, or you say, I had a strange dream, and you go on with your day as if nothing remarkable happened. But something very remarkable happened. You ceased to exist as a conscious being, and then you started existing again. And nobody, not a single physicist, not a single neuroscientist, not a single philosopher on this planet can fully explain how that works or where you went. You see, this is not just a question about sleep. This is a question about the deepest unsolved problem in all of science. What is consciousness? Where does it live? And why can it apparently be switched off and switched back on like a light? Now, before we can talk about what happens to consciousness during sleep, we have to be honest about something. And I think honesty is always the right place to start. I mean, we do not know what consciousness is. Not really. We can describe it. We can measure its correlates. We can point to brain regions that seem necessary for it, but we cannot explain why it exists at all. There was a philosopher named David Chalmers, and in 1995, he articulated something that had been bothering people in one form or another for centuries. He called it the hard problem of consciousness. And here's what he meant. You can describe every single atom in a human brain. You can trace every electrical signal, map every chemical reaction, catalog every neurotransmitter binding to every receptor. You can build a complete physical description of the brain down to the quantum level, and you still have not explained why there is a subjective experience attached to it. Think about that. You see, physics gives us equations for everything. We have equations for gravity, for electromagnetism, for the strong and weak nuclear forces, for the behavior of particles at every scale we have ever measured. But no equation in physics produces the feeling of redness when you look at a sunset. No equation generates the taste of coffee. No equation creates the sense that there is someone, a you, experiencing these things from the inside. Now, this is not a failure of physics. It is just an honest acknowledgement of where we are. And I think it is much more interesting to live not knowing than to have answers which might be wrong. So let me tell you what we do know, because what we do know is fascinating, and it gives us real clues about what might be happening to your consciousness every single night. Well, the first thing I have to tell you is that the brain does not simply turn off when you fall asleep. No, no, no. It changes what it is doing. And the way it changes is very, very specific, and we can measure it. If you take a person who is awake and you stick electrodes on their scalp, what we call an electron filogram or EEG, you see a particular pattern. The neurons are firing in what looks like chaos, high-frequency desynchronized patterns. Well, beta waves, roughly 12 to 30 cycles per second. Different parts of the brain are doing different things at different times. It looks noisy, messy, almost random. Now, here's a way to picture this. Imagine you are in a massive stadium, 100,000 people, and everyone is shouting something different. Someone is yelling about their lunch. Someone else is singing a song. A third person is arguing about politics. The overall sound is a roar, but it is a rich roar. It contains enormous variety. If you could somehow listen carefully enough, you could pick out individual conversations, individual ideas. There is a tremendous amount of information in that noise. Now you fall asleep. Deep sleep, what the scientists call non-REM sleep, the slow wave phase, and something dramatic happens. Those fast desynchronized beta waves are replaced by slow, massive synchronized delta waves, half a cycle to 4 cycles per second. The neurons are no longer shouting different things. They are all doing the same thing at the same time. The stadium is no longer a roar of individual voices. It has become a coordinated wave. You know, the kind where one section stands up and then the next section and then the next, and it rolls around the entire stadium. Now, that looks impressive from the outside. It looks organized. But think about what has been lost when everyone does the wave. Nobody having their own conversation anymore. The individual voices, the individual ideas, the diversity of information, it all gets drowned in the collective rhythm. And this is where the physics gets really interesting. You see, this is fundamentally an information theoretic phenomenon. Information, real information, requires differentiated states. You need things to be distinguishable from one another. If every neuron is doing the same thing at the same time, the number of distinguishable states, the system can be in drops dramatically. The entropy of the system in the information theory sense collapses. Let me put this differently. A brain full of neurons all firing in sync is like a hard drive where every bit has been set to the same value. It does not matter if it is all ones or all zeros. Either way, the storage is empty. The capacity for information is gone. And here is the deep question. If consciousness requires differentiated information processing and deep sleep destroys differentiation, then consciousness should vanish during deep sleep, which is exactly what seems to happen. You do not experience deep sleep. There is no one home. Not because the brain stopped working, but because the brain stopped working in a way that can generate experience. Think about that for a second. Now, there is another piece of the story, and it involves a structure deep in the brain called the thalamus. You see, the thalamus is a relay station. Almost every piece of sensory information that reaches your cortex, the outer layer of the brain where the sophisticated processing happens, almost all of it passes through the thalamus first. Vision, hearing, touch, all of it gets routed through this walnut-sized structure in the middle of your brain. And during wakefulness, the thalamus is wide open. Signals come in from your eyes, your ears, your skin, and the thalamus faithfully passes them along to the cortex. You hear the clock ticking. You feel the fabric of your shirt. You see the light in the room. But during deep sleep, something remarkable happens. Thalamic neurons enter what physicists and neuroscientists call a B-stable mode. They oscillate between two states. An up state where the neuron is depolarized and responsive, ready to pass signals along, and a down state where the neuron is hyperpolarized and silent, completely silent. During those down states, sensory signals cannot pass through. The gate is shut, and this is not a gradual dimming. This is very important. The thalamus does not slowly turn down the volume like a dimmer switch. It flips like a phase transition. You know what a phase transition is? It is when water freezes. At 33 degree F, you have liquid water. At 34 degree, you have ice. There is no gradual transition between liquid and solid. It flips. The thalamus does the same thing. One moment it is passing signals. The next moment it is not. Now, this is why you do not hear the clock ticking during deep sleep. The signal from your ears reaches the thalamus and gets stopped at the gate. But here is something very interesting. A loud enough noise can still wake you up. Why? Because the signal has to be strong enough to overcome the hyperpolarization barrier. It has to have enough energy to force the thalamic neurons out of their down state. It is a threshold phenomenon. Small signals get blocked. Large signals break through. And you know what? This tells us something important. The brain during deep sleep is not unconscious because it cannot process anything at all. It is unconscious because it has raised the barrier so high that only extreme signals can get in. And even those, when they do get in, they don't produce a normal, conscious experience. They just trigger an alarm, a wake-up signal. So the brain has physically disconnected itself from the external world. The stadium is still there, the seats are still there, the people are still there, but the doors are locked and the windows are shuttered. Now, I want to tell you about something that I think is one of the most beautiful and provocative ideas in modern neuroscience. There was a neuroscientist named Julio Tony working at the University of Wisconsin, and he developed something called integrated information theory. Now, this is a theory that tries to do something very ambitious. It tries to give consciousness a mathematical definition. You see, Tononi proposed that consciousness corresponds to something he called phi, and phi is a measure of integrated information, the degree to which a system generates information above and beyond what its individual parts generate separately. Let me explain what that means, because it is actually quite intuitive when you think about it. Imagine you have two completely separate computers. Each one processes information on its own. They never talk to each other. The total information in the system is just the sum of what each computer does independently. Phi, in that case, is zero. There is no integration. Now connect those computers. Let them share information, influence each other, create patterns that neither one could create alone. Now, the system generates information that is more than the sum of its parts. Phi goes up. The system is integrated. Tony's claim is that consciousness is what integrated information feels like from the inside. High phi, high consciousness. Low phi, low consciousness. Zero I, no consciousness at all. Now, you might think this is just philosophy, just a nice idea with no way to test it. But here is where it gets really interesting. There was an experiment, and I love this experiment because it is one of those rare cases where you can actually see the theory playing out in front of your eyes. The technique is called transcranial magnetic stimulation, or TMS. You hold a device against someone's skull and fire a magnetic pulse that stimulates the cortex directly. And then you watch what happens using EEG. When you do this to a person who is awake, the pulse creates a complex, widespread response. The signal ripples out from the stimulation point and echoes across the brain. It bounces between regions. Different areas respond at different times with different patterns. The response is rich, differentiated, integrated. It looks like dropping a pebble into a pond and watching the ripples spread in complex interacting patterns. Now you do the same thing to the same person during deep sleep. Same pulse, same location, same magnetic field strength. And what happens? The response is simple, local, and it just collapses and disappears almost immediately. The signal stays right where you put it. It does not spread. It does not integrate. It is like dropping that same pebble into thick mud. A little splash and nothing more. Think about that. The brain is still alive. The neurons are still there, but the system has lost its ability to integrate information across regions. The cortex had broken into isolated modules, little islands that cannot communicate with each other. And according to integrated information theory, that is exactly why consciousness disappears. Phi drops and the lights go out. Now, I should tell you that integrated information theory is not universally accepted. There are physicists and philosophers who have serious objections. Some argue that phi is too hard to compute for any realistic system. Others argue that any theory that assigns consciousness to a mathematical quantity is making a category error, and those are fair criticisms. But the TMS experiment is not a matter of interpretation. That data is real. Like whatever consciousness is, it correlates with the brain's ability to integrate information. That much we can see. Now, here is where the story takes a strange turn. Because consciousness does come back during sleep. Not all at once and not in its normal form, but it comes back. And when it does, it comes back scrambled. You see, about 90 minutes after you fall asleep, your brain enters a phase called REM sleep, rapid eye movement. And if you look at the EEG during REM sleep, something surprising happens. The brain waves look almost identical to wakefulness. Fast, desynchronized, high frequency. The thalamocortical gate partially reopens. That the brain is active again in a way that looks from the outside very much like being awake, and you are conscious again. That is what dreams are. They are consciousness returning during sleep. You see things, hear things, feel emotions, move or through ways to these spaces, interact with people. There is genuine subjective experience happening during REM sleep, but there is a catch, and it is a very interesting catch. The prefrontal cortex, the part of the brain responsible for executive control, logical reasoning, critical thinking, self-awareness, the part that makes you say, wait, this does not make sense, that part is largely offline during REM sleep. So what you get is consciousness without a reality checker. Your brain is generating vivid, complex experiences, but it is working with internal noise instead of external input. It is hallucinating, and you do not know you are hallucinating because the machinery that would normally flag the experience as not real is shut down. Now, I want to give you a physics parallel here because I think it is illuminating. Imagine you have a complex dynamical system, a set of equations that describe how something evolves over time. During wakefulness, those equations run with real boundary conditions, real input from the external world. Light comes in through your eyes, sound comes in through your ears, and the equations process real data. And during REM sleep, the same equations run, the same dynamical processes unfold, but the boundary conditions have changed. Instead of external input, the brain feeds itself internal noise, random signals generated by the brain stem, fragments of memory, emotional residue, same equation, different input, same engine, different fuel. And the result is a world that feels real, but it's entirely fabricated. And you know what? This might be the most unsettling thing about dreams. Not that they are strange, but that they demonstrate how thin the line is between perception and hallucination. Your brain constructs your entire experience of reality. During the day, it constructs it from external data. During REM sleep, it constructs it from nothing. And in both cases, the experience feels absolutely convincingly real. Now, this opens up a whole question. If we really want to understand what sleep does to consciousness, it helps to have a control experiment. And nature has not given us one. But medicine has general anesthesia. You see, under general anesthesia, consciousness disappears far more completely than it does during sleep. And when you go under with drug like Propol, there are no dreams. There is no REM-like return of experience. There is nothing. And the patients report that it is like a gap in time. For one moment they are counting backward from 10. The next moment they are in a recovery room and hours have passed. And what Propol does at the neural level is very revealing. It disrupts cortical connectivity at a fundamental level. It breaks the integration that Tony's theory says is necessary for consciousness. It does not just raise the thymic gate or synchronize the neurons. It fragments the cortex far more severely than natural sleep does. Now, this contrast is very important. During natural sleep, consciousness is reduced in stages. You lose it during deep non-REM sleep, but it comes back, albeit scrambled during REM. The brain cycles through these phases all night long. It is a natural, reversible, rhythmic process. Anesthesia is different. Anesthesia is closer to just unplugging the system entirely. And this tells us something. It strengthens the argument that consciousness is not about how many neurons are firing or how much energy the brain is consuming or whether the brain is active or inactive. The brain under anesthesia is still active. Neurons still fire. Metabolism continues. But the pattern of activity, the integration, the connectivity between regions, that is what has been destroyed. And with it, consciousness vanishes. So consciousness seems to track integration, not mere activity. The brain can be buzzing with electrical signals and still have nobody home if those signals are not integrated into a unified whole. Now, let me tell you where this leaves us, because I have been building up to something, and I think it is important to say it plainly. We do not fully know where consciousness goes during sleep. And the reason we do not fully know is that we do not fully know what consciousness is. We have clues, beautiful, compelling, experimentally grounded clues. We know that consciousness correlates with integrated differentiated neural activity. We know that deep sleep destroys both the integration and the differentiation. We know that the thalamus acts as a gate that physically disconnects the cortex from the outside world. We know that when REM brings back something resembling wakefulness, consciousness returns, but in a distorted, uncontrolled form. We know that anesthesia can destroy consciousness even more completely than sleep by breaking cortical integration at an even deeper level. All of this is real. All of this is measurable. And all of it points in the same direction. Consciousness is not a thing that lives in a particular place in the brain. It is a process, a pattern, a way the brain organizes information. When that pattern collapses during deep sleep, consciousness collapses with it. When the pattern reassembles during REM or upon waking, consciousness reassembles. All right, but here's what keeps me up at night, and I apologize for the pun. The neurons are still there during deep sleep. The chemistry still runs. The physical structure of the brain is intact. Nothing has been removed. It is the same brain with the same parts made of the same atoms. But something, the integrated, differentiated, self-referential processing that makes you you, that thing collapses. And it does so every single night. and then it reassembles every single morning. And now I want to come back to where we started, because I think the deepest mystery is not the one most people focus on. You wake up every morning and you feel like the same person who fell asleep. You remember your name, you recognize your house, you have the same worries, the same plans, the same personality, continuity. It feels seamless, but it is not seamless, not physically. While you were unconscious, your brain was extraordinarily busy. Synapses were pruned, others were strengthened. Memories were consolidated, moved from short-term storage to long-term storage, reorganized. Waste products were cleared out of the cerebral spinal fluid. Proteins were synthesized. The you that wakes up is physically different from the you that fell asleep. Different synaptic strength, different molecular configuration, different patterns of connectivity, and yet the sense of being you persists. The subjective feeling of continuity survives a nightly demolition and reconstruction of the very hardware it runs on. Think about that. People ask the question, where does consciousness go during sleep? And I understand why they ask it, because it feels like consciousness is a thing, a possession, something you have that can be misplaced, like your keys. Where did it go? Where did I put it? But I do not think that is quite the right question. Consciousness is not a thing that goes somewhere. It is more like a flame. Where does a flame go when you blow it out? It does not go anywhere. The conditions that sustained it, the heat, the fuel, the oxygen, those conditions changed. The flame did not relocate. It ceased. And when you strike the match again, you do not get the same flame back. You get a new one, but it looks the same. It feels the same. And maybe that is what happens every night. Maybe the consciousness that wakes up is not the same consciousness that fell asleep. Maybe it is a new flame lit from the same materials in the same configuration, carrying the same memories. And maybe the continuity you feel, the sense that you are the same person, is not a fact about consciousness itself. It is a story the brain tells, reconstructed fresh each morning from the records it kept overnight. I do not know if that is true. Nobody knows. And I think that is the honest answer. We do not know, not yet. But I will tell you what I find beautiful about this. Every night the universe runs an experiment. It takes a conscious being. It disassembles the conditions that produce consciousness, and then it reassembles them. And every morning a person wakes up and says, I am still here. The same atoms, mostly the same connections. A rebuilt pattern that insists it was never interrupted. The real question is not where does consciousness go when you sleep? The real question is, why does it come back as you? And that, I think, is one of the most wonderful unsolved questions in all of science. We do not know the answer. We keep looking, and that is how it should